Hello, friends. Today, we're going to talk about our digital oscilloscope. This is a 4-channel color-coded digital oscilloscope that you will likely have the privilege of using this semester. So we just want to do a little bit of an oscilloscope review. And why is that? Is because unfortunately, sometimes people don't get the right results with their oscilloscope. So they'll spend about half an hour troubleshooting their circuit, only to find that there was nothing wrong with the circuit all along, but instead they had their oscilloscope set improperly. So we don't want that to happen to you. So let's talk about how to use the oscilloscope properly. We're going to talk about how to set it up. And we're going to talk about some common features that people have issues with or that could be beneficial to you. And lastly, we're going to talk about how to connect an oscilloscope to the circuit and how you can't connect it. Some people connect it in a way that it shorts out part of their circuit. So let's start out with turning this one on. So one way that you can start off on a good foot is to make sure that your oscilloscope is calibrated properly. So if it's calibrated properly, that's going to check that the oscilloscope is working, and it's also going to check that your leads are working. So something over here, you might see this exposed metal down here. So what that is that's a calibration point. So all oscilloscopes have those calibration points. So I'm going to lift this up for a moment, and you're going to see an old analog oscilloscope. And down here, it has a little piece of metal sticking out, and it says cal. So all oscilloscopes have the calibration point. So how do we use the calibration point? Well, first of all, the first thing you want to do is make sure that your ground is centered. So on this model, we're going to press channel 1, and we get the channel 1 menu. I realize that it's not as crisp as I would like, but you'll see and you'll be able to get the point. So our first thing is our coupling is DC. So I'm going to press that, and I'm going to use this to adjust it down to ground. And then I'm going to press this bottom arrow key. And now our coupling is ground. So we're able to adjust the ground. So we see that it was already pretty much on center for us. So sorry, I'll do it without my hand in the way. So that's the first thing you need to do. If the ground isn't centered, you're gonna maybe have some troubles interpreting your signal. So now we'll go back to DC. And again, I'm gonna press this little arrow, and we're on DC. So how do we use the calibration point? Well, the first thing we're going to do is we're going to connect our scope lead to channel 1. And we see the end of our scope lead, we have the probe and we have the ground. One thing you want to do is make sure that your probe is set to ×1, which it is. If you set it to 10 times, you might have some issues. So we're going to clip the probe portion onto our calibration point. And we see a waveform. So did you notice I didn't have to clip on the ground? I just clipped on the probe. Now why that is this test point is internally grounded. So the probe ground is already connected inside the oscilloscope. So you just have to worry about connecting the probe. So this is the calibration we're looking for. If you look at the bottom left, it will say 1 volt. So I'm able to adjust that over here and see now it's 500 millivolts, 1 volt, 2 volts. So at 2 volts, it takes up 1.5 divisions. So 2 times 1.5 is 3, but of course it's easier just to leave it at 1 volt. And now we'll see it takes 1, 2, 3 divisions. So 3 times 1 is going to give us 3 volts. So this is an important thing to note. When you're setting it up, you are looking for these numbers. You are looking for 3 volts. So over here, when we're in the menu for channel 1, it says probe times 1. So we're actually able to change that from times 1. Let's change it to times 10. And I'll hit the select button. So our picture hasn't changed, but if we look down at the bottom, it says 10 volts per division. So if I was looking at this, I would count 1, 2, 3 divisions multiplied by 10. I would say that this is a 30-volt signal. So that's a problem, because when people use these oscilloscopes, it saves the last setting. Also, on this oscilloscope, they have an auto range button. So sometimes instead of adjusting the vertical and the horizontal or the time and the voltage, people will just hit auto. But what they don't realize is sometimes it changes the probe number. So I've seen a lot of people get answers that are completely wrong because their probe has a multiplier on it and they don't know that. So by calibrating it, we'll be able to see clearly if our signal isn't 3 volts, then we have a problem. So put the probe back to 1. Another thing we'll see is that our time division is 500 microseconds. 500 microseconds. So you see this period repeats. It has an upper portion and a lower portion, and each one is taking up 1 box. So we have 2 times 500 micro, and that gives us 1 millisecond. Now, if you take 1 and divide it by 1 millisecond, you'll get the frequency, right? And that's going to be 1 kilohertz. So when I connect my probe here to the calibration point, I'm expecting to see a 3-volt square waveform. And I'm also expecting to see a period of 1 milliseconds and a frequency of 1000. So I calculated these 2 items, but they show down here. So before you use it, you set the ground, just as a review. You make sure that the ground is in the center, and then you calibrate it and make sure you're getting that 3-volt square waveform. If you don't see this, it means some sort of setting is wrong, and you want to correct it before you start setting up your circuit. Now, another thing to note is there's a button over here. Now we're going from how to use it to common features. There's a button here that says measure. So as you can tell, just like any oscilloscope, even an analog oscilloscope, you can count your boxes, you can do your calculations. I'm a little on the older side, so that's what I like to do. But you can hit measure, and on your menus here, there's one thing that says measure all, and right now it's off. If I press the button next to it, measure all is on. And now you have all this information. It shows that our max for channel 1 is 3.04 volts. It shows the min, which is negative 40 millivolts. So that means our ground is just slightly below. It shows our peak to peak. It shows our amplitude. It shows our volts RMS. It shows the positive and negative side of our duty cycle. It shows our frequency. It shows our period. It has a ton of information. But if somebody has the menu on and they turn it off and put the scope away, and then you come in the next class and use it, this menu will appear. So as you can tell, it is obscuring our waveform quite a bit. So how do you turn it off? Well, you press the measure button, and then you go to measure all, and you turn it off. There's another way to get measurements on this. So measure all is a big one, but under the measure button, there's something called cursor. So if I press it and I press it again, you see this little menu appears right here. So the cursor button, we're able to move a cursor around and get information on a certain point on the screen. But typically, it's just in the way. So I can hit the cursor button a few times and it disappears. So that's essentially how you set up your oscilloscope. That's essentially the two menus. People are looking for them, or they're in the way and they want them gone. So that's a big thing with this oscilloscope. But clearly, we're not going to run through all the features. It's about a 250-page manual for it. But those are the ones that differ a lot. You know, if I'm changing my voltage here, that's volts per division, and you see it in the bottom corner change. Or if I wanted to change my time period, I use over here my horizontal control, and it changes my time period, and that shows up here. So in that way, it's just like a regular oscilloscope, of course. So let's talk about our last feature, how you can connect an oscilloscope to a circuit and how you cannot connect it to a circuit. Just going to see if I can put this here. So what we have is a simple series circuit, red. Let's call that 5 volts DC, and it's going through one resistor, a second resistor, and a third resistor. And then it's coming to ground. Well, let's call it 6 volts DC. Why would I call it 6 volts DC? Because the resistors are all the same. So the voltage here would be 2 volts. On the second resistor, 2 volts. On the third resistor, 2 volts. So if I took my trusty multimeter and I set it to DC and I connected it across the whole circuit with my black as my reference, I would get 6 volts. But this reference is not ground. It's just a black wire that's a reference on our multimeter. So I could move it up here and get 2 volts. Or I could move it to the middle and get 2 volts. Or on the bottom and get 2 volts. I can use my multimeter voltage any way that I want. Now, is that true about the oscilloscope? Well, no, it is not. So what's different? Well, what's different is that the ground of the oscilloscope is connected to earth ground inside your meter. So that means I would always have to clip it to earth ground. So then I could move my probe here to measure 2 volts, here to measure 4 volts, or here to measure all 6 volts. But what would happen if I put my ground there? Well, I think you'll see power will come in, go through one resistor, and then go to ground. So instead of 2 volts on each resistor, I'm now putting 6 volts over the top resistor. That, of course, could cause it to overheat depending on its power rating. Depending on the type of circuit, you could short out and destroy a component. So the difference is with the oscilloscope is your black wire here, or the clip, is earth ground. So for DC circuits or circuits that have a ground, you have to be very careful. And this probe, this ground always has to go on the ground of the circuit. Now, let's change it around a little bit. This is no longer 5 volts DC. Let's say 6 volts DC. Let's say it's AC. Let's say it's the second side of a transformer. So as you know, on the secondary side of a transformer, if you don't connect it to ground, it's floating. It really doesn't have a ground reference. So if this was AC and this is on the secondary side of a transformer, then could I put my meter here just over the first resistor? Yes, I could, because this wouldn't be shorting it to ground because my circuit is not connected to ground. So that's the difference. I could connect it anywhere I wanted, just as I can with my multimeter. But when your circuit already has a ground, this always has to be connected to ground. You cannot have 2 different ground points on your circuit, or as we mentioned, you could short components, damage components, fry components. So hopefully this has been an informative video. Many people do not like oscilloscopes because of the complexity of them and by remembering the different rules. But if you set it up properly, if you take the 1 minute, it's not even 2 minutes, the 1 minute to calibrate it, you're going to have a tool that you can trust, and it's going to give you awesome readings, and it's going to really enhance your electronics experience. So my name is Jordan Mancini, and I hope this video was helpful for you.